Interfaces in Unreal. It's going to be a quick high-level overview. So there's three types of interfaces you can have in Unreal. There's the interfaces that are inherited in code. There's the interfaces that could be inherited from in code or Blueprint. And then there's the Blueprint-only interfaces, which only exist in the editor with a U asset. This is a shortened video of a longer video on my channel. So after watching this, if you want more context, then watch the full video. And so interfaces have two types. So interfaces have two types, the UType and the IType. And the first thing you do is you define a class that inherits from the UInterface type. So this is the UType. And the next thing you define is a IType, which has no inheritance. And the UType is sort of like a reflection type. So you specify things like it's a blueprint type or it's blueprintable, so Blueprint can inherit from this interface. The IType is where the actual interface stuff goes, so the functions. So why interfaces? Interfaces make code more generic. For example, we could make a use system that can operate on usable interfaces. So we're kind of extracting the idea of using something. So the system doesn't need to know if a usable object is a door or like a light switch. The door can implement its usability in its own way, where if it gets used, then it pivots a mesh in 3D. Or the light switch can implement usability in its own way, where it enables or disables a point light based on whether or not it's used in the current state. And so there's Blueprintable and not Blueprintable interfaces. Blueprintable can be inherited in code or Blueprint, and not Blueprintable can only be inherited from in code. So here we have a Blueprintable interface. So make our UType from UInterface, make our IType. And since this one is Blueprintable, we can make these Blueprintable events. And we can also make BlueprintNativeEvents, and we can define our default function here. But what we cannot do is define a Blueprint callable function. Here's the compiler error you get if you try to do that, and we'll get a little bit more into that in a moment. It has to do with, I believe, complexity around the IType. But if we look at the not Blueprintable one, so again, you make a UInterface, and this can only be inherited from in code. We make an IType, and this one can actually have Blueprint callable functions. But what it cannot have is Blueprint implementable events and Blueprint native events. If you try to do that, you'll get this compiler error here. What it can do, though, is have a virtual function that is completely in code. And this has to do with around the complexity of effectively Blueprintable interfaces not having an IType if a Blueprint implements event, but we'll get into that in a moment. And so let's consider these situations. We have the code-only ones, so the not Blueprintables. We have the either-or case, so the Blueprintable ones, code or Blueprint. And we have the Blueprint-only. So the first thing we do is we make our UType, then we have our IType. We'll also have a code actor type, and we'll have a Blueprint actor that is going to inherit from our code. The actor in the editor inherits from the actor we define in code. Now, this one inherits from the IType. So we think of the actor as inheriting from the IType of the two interface types. When it comes to the Blueprint side of things, we still have a UType and an IType. And now we have a Blueprint actor, but there's no code actor in between. So which does this inherit from? Well, I think of it as inheriting from the UType, the reflected type. It's not like it inherits from the IType like the code actor did. If we look back, code actor is going up to the IType. And this is sort of a mental model. It may not necessarily be entirely true. When you set something in Blueprint, it's not running a C++ compiler. It is running a Blueprint compiler, but it's not running a C++ compiler. So the way I think about this is we're not actually ever compiling any of this into C++. But this does still define what functions are available. And so if we were to do this entirely in Blueprint, we have the Blueprint interface, which you make an asset, and you add functions to it here, and then we set it in the implemented interfaces of a Blueprint actor. And so I think of that inheritance as just the actor inheriting from the asset. And so to review that, we have a Blueprint actor that might inherit from a code actor, which inherits from the I interface. And we have a Blueprint only actor, which directly inherits from the U interface. And then for the Blueprint only side of it, it's a Blueprint actor inheriting from a Blueprint asset. So that's how the inheritance works between the three. And this is also how it works for code only. For code only interfaces, it only does that part. And so why do we have this distinction here where it's like, okay, this inherits from I, but we don't think about the Blueprint one inheriting from the I, we think about it inheriting from the U interface, the reflected type. This mental model is useful because it explains some behaviors you'll see in other parts of the engine. You may be used to casting an actor to an actor type and then calling a function based off that actor type. And you can do the same thing with interfaces. You can cast a actor to an interface and it'll return null if it's not an interface, or it'll return not null if it's implementing the interface. And you can call a function. However, this is only true for things implementing the I interface, so the code actors. It's not true for a Blueprint implementing a Blueprintable interface. This will return no pointer. And so to handle that, you need something that works for both cases. And notice in this case here, we are casting to the I type, not the U type. The thing that works in both cases, we are actually using the U type here, And there's a function called implements, and you pass in the type here. And this will return true if it implements this interface. If it does implement it, this is like a type check at runtime, we can use this special generated function for the interface type. And notice this is the IType. And it says execute underscore, and then it's the function name we defined in the interface, the U function. And so in this way, you can execute it on both the code types and the blueprint types. And so you have these two choices, and sometimes it does make sense for this, code only. Sometimes it makes sense for this, where it's blueprintable. So just to drive that home, in the blueprintable side of it, we have the code implementers and we have the blueprint implementers. And this version works for both of those. And for the code only interfaces, so we can only have this situation, it's okay to cast IInterface. And you do actually have to use this in some cases for code only interfaces, because you may add virtual functions that are not U functions and code only functions. There's a subtlety in regards to passing parameters. So here we have this function that takes in a single float parameter, and this time we want to pass the argument called argument value to it, which is just set to 2. Now we have to remember both of these situations, at least for blueprintable interfaces. So we have the interface on the left, which is code interface on the right, which is blueprint. And to invoke that method that we wrote on the interface on both of those, we actually use the execute function. So the function is the function we wrote, prefixed with execute. And so we have the single float parameter, and we're going to pass in the argument value. And we pass it in here, which, if you notice, is actually the second argument to this execute function. The first argument is the actor that we are operating on, because this is effectively like a static function defined by the interface. So there's no object associated with this function call. And so we have to pass the object that we want to invoke this function on to the execute function. And so how do we communicate about interfaces across the code and blueprint boundary? There's a special type called the TScriptInterface. And notice it takes the IType. Now this will work for blueprints and code interfaces if it's a blueprintable interface, but it does take the IType. There is still some caveats to this. And so let's say, how do we actually make one of these? The first thing we want to do is we want to make sure it actually is of this interface type. And so we can call the function implements. And again, notice this is the UType, not the IType here. And so if this other actor implements the interface, we're going to make a TScript object and we'll send that to the blueprint. And so what you can do is you can directly assign the other actor to the interface. And just so you know that the other actor is just a pointer. And so we directly assign to it, and this gives us some new functions. There is a function called getObject on this script interface, and it'll return an object pointer of the thing that implemented the interface. And there's another function called getInterface, which will return an interface pointer to the thing that implemented the interface. Now, here's where some of the behavior that the mental model explains comes into play. If you pass in a code actor, you can get a valid pointer for the object, and you can get a valid pointer for the IInterface. If you pass in a blueprint actor, then you'll get a valid pointer for the object, but you will not get a valid pointer for the interface. This will be null pointer. And that's kind of the behavior of the IInterface not existing in the blueprint. Now you can send this to blueprint. So I have a function here, send interface to blueprint. And the way that looks is we have a Blueprintable event, and we're passing in a const TScriptInterface. And notice it's the IType and the interface name. And so this is how you can send something on the code side to Blueprint that's implementing the interface. You wrap it in this TScriptInterface. So we have blueprintable and not blueprintable. Again, not blueprintable has blueprint callables, can have virtual functions because they're always is basically guaranteed to exist this IInterface. For the blueprintable ones, though, this IInterface only exists half the time when it's implemented in code, but not blueprint. And so that's why you have these blueprint implementable events, because we expect that a blueprint is basically going to exist. And you have to use that special implements and execute functions to actually call these. You can actually have a virtual function that is associated with this blueprint native event, and we can explore how that works. So if you're going to blueprint, you say, hey, I want to implement my blueprint interface, you can do that by setting it here, and you have these two functions that are defined in code. And let's say you actually don't override the thing that's supposed to return, the blueprint native event with a return. What happens? So in code, we have this function that takes in the float, and it's going to just return that float back. This is the default implementation that Blueprint did not override here, because this is great. So if the IInterface doesn't exist, then this should be an issue, right? So how does the engine handle that? So I've debugged it here, and it actually returns a default value. So I'm calling the execute blueprint thing with return, and I'm passing in the argument 2. And the return value should be 2 if it used the default implementation. But again, it's as if this I implementation doesn't exist. It returned 1. It returned a default value. So again, the mental model kind of explains this behavior that you see of there not really existing an IInterface when it comes to Blueprint implementing a Blueprintable event. So imagine this is because it can't actually call the function. This is a member function. It needs an object that is of this type. And when we implement something in Blueprint, we're not running the C++ compiler, it's doing the Blueprint compiler, but that's all using like reflection with C++, it seems. And so what's it do here? It just returns a default value of a float, which is 0, because it can't actually run this function that doesn't exist for that particular type. It's not compiled in. And so if you go into Blueprint and you do override this native event, so we have the interface and we override it, and you try to call the parent function, this is grayed out. And again, this is explained by the mental model of there not being an IInterface for blueprints implementing a blueprintable interface defined in code. There is this TSubclassOf, and TSubclassOf allows you to basically have a reflected class and do things with it. And say you want to constrain that to an interface, you can use this meta specifier for MustImplement and the interface name. And there's another version of this, the meta MustImplement, and you can specify the module name just in case there's multiple interfaces with the same name in your project, maybe with multiple plugins. You can be more explicit here. So this is like a full MustImplement, and this is like a minimal, only saying the interface name. If you go into the editor, when you try to select the class to specify here, this will constrain the options you have available here to be of that interface. And if you didn't do that, you'd have like all the actors in your project specifiable here, which we don't want. Let's say you are in a different situation where you did have a TSubclassOf, but it may or may not be that interface. So this is some class that might be the interface. We don't know. How do you find this out at runtime in code? Well, what you can do is call this function that is similar to the other one. And you say ImplementsInterface, and then you'll use the like UType, so the UType, and get the static class, so they're like the reflected class. You can ask if this class implements that interface, then do some logic in response to that. Otherwise, do some other logic. And so this is how you can test. But again, if you want to constrain it to only be that, then use the MustImplements thing we saw in the previous slide here. So as far as Blueprint goes, Blueprint can call functions on interfaces as well. So how does that look? There's really two situations that stand out to me. There is the situation where you have a TScriptInterface, like we saw earlier, directly. So you can call the function directly on this object. And you know it is, you know the type here, it is a test blueprint interface. You can call it directly. The other situation is you just have a generic UObject. So here we don't actually know if this implements the interface, but you can still call this native function here. And this is a special version with a little envelope here. So this is like sending a message. And so this is going to call that function if it actually is that interface. Otherwise, it's just going to do nothing. And so I hope that helps show the surface area of blueprintable interfaces, not blueprintable interfaces, and blueprint defined interfaces. Be sure to check out the full video if you made it this far. This is a condensed version of a longer, more thorough video. Hopefully with this information you can make more informed decisions as to the code you're writing and whether or not you want it to be something in Blueprint and the considerations that need to be involved in that decision, or whether it's appropriate for it to just be a code side interface. So if you have any questions, comments, concerns, or even corrections, please post those in the comments below. And until next time.